It's huge. And obviously in class, we built it up even more than what I just did right there. All right, another way about bringing crap up to the top is coastal upwelling. Coastal upwelling, it's like you got an island or you got land, you got the ocean, and in the ocean there's currents, and these currents are just humming. They're just humming. They're going along just doing nothing. They're like a big underwater river. And then all of a sudden, it hits land. And when it hits land, this bottom current hits the land. And when it hits the land, you guessed it, it mucks up this marine poop. It stirs up this marine poop. And then this current is going like this. And then this current hits the land, and it goes up the land. And yes, it does. It brings the marine poop up with it, up to the photic zone. Another way of bringing poop up to the photic zone. Man. Then we talked about Hawaii. We said Hawaii is an island. We said one side of Hawaii has a whole lot of life. The other side of Hawaii, not much life. I think you see where we're going. The side of Hawaii where the currents are hitting the land, the poop is being brought up to the top. The other side of Hawaii, the currents are just going like this. And because the currents are going like that, there's no poop being brought up to the top. Tourists, they like to go to this side of Hawaii because the water's super clear. There's a 90-foot photic zone. This side doesn't have much life. The people that live in Hawaii, they go to this side because this side, the currents are being brought up to the top. Poop is coming up to the top. There's going to be a lot of algae. There's going to be a 15-foot photic zone here. There's going to be a lot of life. This is where they're going to catch all the fish. Nice. The biggest concept in marine biology, somehow you got to get poop up to the photic zone. Another way that this happens is called the Coriolis effect. To explain the Coriolis effect, we went like this, and we draw the world, and we said it happens right here at the equator because the trade winds are blowing. And then what we did is we drew the ocean. We said this is Asia and Australia and over there. And then we said this is the ocean, and then this is Mexico. And then we draw the whole Pacific Ocean like this. The Coriolis effect only happens at the equator because the trade winds are two parallel winds that are really blowing right next to each other. Smartboard, draw the trade winds. Since these two parallel winds are always blowing right next to each other, it actually moves quite a bit of water. So then what we did is we focused on this water molecule right here by Mexico. Trade winds blow. What happened to that water molecule? Yeah, it blew away. So then we focused on this water molecule underneath that. Well, if that water molecule blows away, what does it have to do? Yeah, you're right. It comes up. Smartboard, blow. That water molecule blew away. I think you see what I'm going to do. All these water molecules eventually go to the top. And then as they go to the top, they get blown away. Oh my goodness. What's eventually going to happen? Water from the bottom is going to come to the top. And as it comes to the top, what is it going to bring with it? Yes, marine poop. Eventually it's going to come to the top. And the trade winds are going to blow it away. And it's going to go across the equator like this. If there's poop, what is it going to be? Algae. Yes, another way of bringing poop to the top. The trade winds are blowing the top layer of water away. Water from underneath that's got to come up and replace it. And as the water from the bottom comes up to the top, it brings that marine poop with it. And it goes across. We said that means there's going to be some algae here at the equator. If there's algae, there's going to be some food chain. Yes, that's why you could catch the marlin, the swordfish, and the sailfish right there at the equator. Then we try to quantify it a little bit. We said, what do you think brings the most poop, the second most poop, and maybe the least poop? We thought about it for a while. What we said is, I bet you this winter upwelling, where the whole top of the ocean sinks down to the bottom and mucks up the bottom, brings to the top. That's got to bring the most poop. That's ranked number one. And then what we said, I bet you this coastal upwelling, where the currents are just hitting the land and mucking up the bottom, bringing it to the top, I bet you that's number two. And we said, this Coriolis effect, it brings up some poop, not a whole lot. We'd rank that number three. We're doing it, class. Another thing we talked about were Langmuir cells. A Langmuir cell is a miniature Coriolis effect. It's a Coriolis effect on a small scale. It happens because sometimes there's two parallel wind currents. Sometimes in the Puget Sound, on a nice summer day, you get it. You get a wind blowing there and a wind blowing there. You get two parallel wind currents blowing like this, and like the trade winds, they blow a little bit of water away. Then water from underneath that's got to come up and replace it. Water from underneath that, and eventually water from the bottoms comes to the top. Another way of bringing poop to the photosome. It's a Coriolis effect on an itsy bitsy tiny scale. You know that a Langmuir cell is happening because something forms. A brown streak of foam. Sometimes you're out there in the Puget Sound, it's a beautiful calm day, and then out of this nowhere, you just look somewhere, and there's just a brown streak of foam forming. It's a Langmuir cell. Characterized by a brown streak of foam. You rednecks out there, I'm always trying to make you a better redneck. You're out there salmon fishing, you see a brown streak of foam, what are you going to do? Go fishing right in that brown streak of foam. Man, poop's being brought up to the top. That means there's going to be a lot of algae growing in that area. If there's algae, there's going to be a whole bunch of little things eating the algae. If there's little things, there's going to be bigger things eating that. Eventually, there's going to be things like salmon, and the salmon are going to be eating there. So that is going to start the food chain. It's the biggest concept in marine biology. It's huge. We're going to be talking about it a whole lot. Hopefully you understand that. I'm going to make a third video that shows your homework assignment and what you have to do for that. So I end this, I start that.